The purpose of the lab is to graph and visualize projectile motion and compare the difference in models when the force of drag is considered. In this lab, we use the tracker software to video the paper ball being thrown and measure the change of position and change of velocity of the paper ball relative to time. In this case, the only part of the path observed is after the max height. We also use code and GlowScript to model the throwing of the paper ball and predict how the position and velocity would change. We do this while not accounting for drag and then accounting for drag later. And in the end, the code and tracker software produce different values. This is because of the lack of consideration for drag and initial velocity from the max height, which was not accounted for. Okay, the main principle is the momentum principle, which states that a change in momentum equals the net force multiplied by time. This means that momentum and therefore velocity changes when there's a net force acting on the object. Okay, so in this experiment, the paper ball was thrown at an angle to the horizontal, going up, reaching max height, and then going back down. Gravity is always acting downwards, meaning there's a net force acting on the ball. If we account for drag, which acts opposite the motion, it is possible to have a net force of 0, which is terminal velocity. The tracker output this data of the x and y position where y is changing at a non-constant rate. Okay, so this was some of the GlowScript code. The first part initialized the position and velocity. The second part made the loop only go until 0.267 seconds. And then the next part computes the net force from gravity and from drag when it does not equal 0. And the last part updates position and velocity. Okay, so this is what was output when there was no drag, which the coefficient was 0. This is what was output when there was drag, and the coefficient equaled 0.0061, which was calculated from tracker. Okay, now the graphs from the tracker data and GlowScript data were extremely different. This may have been due to the fact that the GlowScript code ran based on the fact that it had 0 velocity in the y direction at the beginning. However, the tracker y velocity already had a value because the ball came in from out of frame. However, all lines showed that the net force was causing the y velocities become more negative as time progressed. Okay, additional questions was what if, okay, so for this what if question, the time would be longer because there would be a greater initial velocity in the y direction, causing the ball to go higher and take longer to hit the ground, since all the velocity is going up instead of at an angle. For the what does it mean question, the graph with drag might have predicted terminal velocity because the change of velocity becomes less and less as time progresses, meaning it is getting closer to a net force of 0. Yes, okay.